Alright, let's take a look here at something that's not going to be quite as easy as that last one we looked at, where we just had ones and negative ones. But we'll still set this one up the same way. So we're going to start this with a polynomial. And this will be our polynomial that we're going to look at. F of x equals x to the fourth minus x to the third plus x squared minus 3x plus, minus 6. There we go. Alright, so what they want us to do on this one, we want to find the rational zeros. Alright, so let's break this up into a couple parts here. The first part that we're going to look at, the p's and q's. Now remember, the p values are going to come from our -6 there. So if we look at all the values that can possibly come from p, our factors of p would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So those are all my options that are going to give me factors of -6. Now the second part that I want to look at here would be the q's. And the q's are coming from our lead coefficient, which again in this case is 1. So those are our possible q's. So again, pretty simple, plus or minus 1. Now the nice thing about one like this is once we put this together, all we're going to do is do p divided by q. And anytime that our lead coefficient is 1, whatever the constant values were for their factors, put them over 1, you get the same things back. So for this one, all of our possible values, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, they're going to be the only possible rational roots. I know I keep saying the word rational roots, interchangeable with zeros. So they want us to find all of them. These are the possible ones. So where that narrows it down is once I set this up, I want to see which ones will find factors that are going to help me to decide if they can factor into that. So one of them would be 1. So one thing I could do is set this one up in terms of synthetic division. So there's my x to the fourth term, x to the third coefficient, x squared, x, and constant. So right now I've got 8 different possible rational zeros. So we would go through and try those out, and again remember our goal on this one is when we finish out the synthetic here on this step, we want to try to end up with a 0 here. Alright, now I already know the answer, so I'm going to cheat and go ahead here a little bit. So we're going to plug in a -1. So we bring down the first coefficient, and we do -1 times 1 is -1, add them up. -1 times -2 is 2, add those up. -1 times 3 is -3, add those up. And -1 times -6 is 6, add those up, get our 0. Now again, what did that tell us? That tells us that x equals -1 is one of our zeros. So that's good news. So now we would take this down to another step, and we would bring all this down. And again, they want to find all of them. Now again, we found -1 worked. Now it's possible to have a double root and have -1 again. Now again, I'm going to cheat a little bit just to save time. Turns out that 2 is one that works. And again, how do I know? Well, if I do 2 times 1, add these up, 2 times 0, add those up, 2 times 3, add those up, I get 0. So again, x equals 2 is a 0. Now they're both coming from my list of possible rational zeros, so there's two of my possible rational zeros. Now the only other thing that I would have to check would be this bottom, which is actually telling me 1x squared plus 0x plus 3. So if I were to take a look at that and say, alright, x squared plus 3 equals 0, I would get x squared equals negative 3. I'm not going to get a rational value from that. I'm going to get a complex number. So on this one, I could actually stop, and the only rational zeros would be negative 1 and x equals 2. Now again, depending on what they want me to ask, I could take this further and find my values here, but for this particular problem, they only wanted rational zeros, so this was my solution, and that's where I would stop on that one. Alright, let's take a look at a second problem of this type. And this one, we're going to change it a little bit so we have a few extra possibilities. So on this one, we're going to start with f of x equals 2x to the third plus 3x squared minus 8x plus 3. Now, same thing. They want us to find our rational zeros. So exactly the same directions as what we had in our last problem. So we'll walk that out and kind of set it up the exact same way that we just did our last one. So on this one, we'll set up with our p's and q's again. So remember, our p's are coming from our last value here, our constant. So the possible p values, plus or minus 1, plus or minus 3. Right. Our q is coming from our lead coefficient, 2, so a little bit more this time than what we had last time, plus or minus 1, and plus or minus 2 would be our factors. So not a terribly big change as far as the amount of possibilities, but we'll still set these up. So this time our p's over q's, we could have 1 over 1 or 3 over 1, which just gives us 1 or 3. We could have 1 over 2 or 3 over 2. So in this case, we have 8 different possibilities, including some fractions, as which we didn't run into before. So we'll still set this one up the same way. The only difference is, like I said, now you have some different choices here to work with. Now on this one, let's change this up a little bit. We would still set this up with our synthetic. These would be the choices we would pick from. Our coefficients here, there's x to the third, our x squared, x, and constant. So we're going to bring down the 2. And again, if it is a rational zero, we should get 0 for our remainder. Now, like last time, we'll just start out. 1 times 2 is 2. Add those up. 1 times 5 is 5. Add those up. 1 times negative 3 is negative 3. Add those up, and there's our 0. So it did work, which again tells me that x equals 1 is a rational 0. So that one worked. Now again, it's a third power, so there should be 3 of them. Well, the nice thing about this is, once we get this down to quadratic, we've got a lot of ways we can solve this. Now, could I keep doing this as synthetic? Sure, I can do that, and I can keep picking out of my values here. But instead of doing guess and check with that, we're just going to take this, 2x squared plus 5x minus 3, and I'm going to factor it, only because this one is factorable. So I can do a 2x times an x here, and then I can also set up and factor a negative 1 and a positive 3, because now if I were to check this, my first times first is 2x squared, my outside times outside is 6x, inside times inside, negative 1x, they combine to make 5x, and negative 1 times positive 3 is negative 3. So we can get that, and that's going to let me solve the last part of my problem. 2x minus 1 equals 0, which is going to give me x equals 1/2, and x plus 3 equals 0, which gives me x equals negative 3. So x equals 1, x equals 1/2, and x equals negative 3. And again, if you notice, positive 1, positive 1/2, and negative 3 were all part of my list of possible solutions. It just happened that this time, out of 3 possible solutions, all 3 of them just happened to be rational. So that worked out pretty nice. Now, do I have to go to factoring? No. Like I said, I could have done synthetic division again. I could have taken this and plugged it into quadratic formula. You know, we have a lot of options to work with there. Sometimes all those options work, other times we're not so lucky and we have to find the one that does work.